All right, welcome everyone back to another fun-filled video around our fractions. We have been talking about the sums of fractions recently, right? Again, realizing sums, meaning the answer to an addition problem. And we've had a pretty nice thing happening with our denominators lately. In all of our examples up until now, our denominators have been the same, which we found an algorithm that kind of helped us solve that. But today we're going to explore like what happens when our denominators are unlike, what happens when they're not the same. Does this work, right? So let's kind of look at what we were talking about before. Like what we've seen before is like if I had 1/3 and I'm adding 2/3, well, we noticed that the size of my pieces, that denominator, never changed. So that's still thirds. And then I was just adding my numerator. And we were using models to support how that worked, right? But now we're going to have to start asking this question. It's like, what starts happening when it's not always the same? Like, what does happen when my denominators are unlike? What happens when I have 2/4 and I need to add 1/2 to that? What is the process? So that's today's video. We're going to explore this. And so I say we just go ahead and jump in and do it. So 2/4 and 1/2. There's our first example, right? Now, we had kind of talked earlier. In theory, when you first look at this, one might just say, oh, well, okay, great. 2 plus 1 in my numerators is 3, and 4 plus 2 is 6. So this must be 3/6. But you have to remember that what we've been looking at, and that definitely is not right, it doesn't work, but what we've been looking at is this idea that the denominator talks about really about the number of pieces that your model is being cut into. And so if we thought about modeling that, right, we thought about how we could model to see these two fractions. That might help us put them together. Let's kind of take a look at that. So this would be 1/2. This would be 2/4. Well, all right, if we looked at something like this, we can see that we have different size pieces, right? We have something that's this large. Right, so let's just say it's like this large, and we're trying to add something that's like this to it. And that's not going to work as equally as we need it to be. Like trying to put together these two pieces doesn't really make sense of how we could put all of this together. So we have to start exploring this new idea of I guess, what we knew before. That idea of like, can we then think about how to cut things into the same amount of pieces, right? If I was to go here, well, now all of a sudden I am cutting everything into 4 pieces, aren't I? Right? I can do this. And if I do it that way, it's this idea that maybe I'm creating an equivalent fraction where now if I look at this, I actually have 1, 2 over here, 2/4, and over here I have 4 again. It was 1/2, now it's 4, right? This was equivalent. And I have 2 pieces. So altogether I have 4 out of 4, or 1, if we were to put them all together. So let's explore that a little more. Let's kind of think about what just happened there and how that worked. I'm going to go ahead and take 1/3 and let's do 1/6. Let's just put those together. Okay. So what we just realized is that if we were to model these, before we model them, we actually need to think about the denominator. What's been great all the way so far is that when our denominator is the same, then we can just think about adding our numerators together. Well, in this case, our denominator is not the same, but we can make an equivalent fraction, right? We've done that. That's another unit. We've talked about it. There's videos on that. If you don't remember, you can go back and watch that. Like, how do we create equivalent fractions? And maybe we want to start thinking about, oh, cool. Let me use this skill I have of equivalent fractions to be able to add these unlike denominators together. So what I mean by that is this, let's think about what we might be able to partition our fractions into so that they are the same. All right, so this is 1/6 and this is 1/3. So here, I'm gonna shade that in first so we can kind of take a look at it. And I might want to think, all right, well, let's make one of these an equivalent fraction. Let's partition one of these fractions in a way to where they're the same. Like, can I make this fraction out of 3 parts? Like, can I just erase that line and all's good? I don't know if that's going to work. I don't know if we have the right just to take things away. Or can I look over here and say, oh, well, maybe there's a way to partition this fraction so that can make 6. And I can, look, boom. Now, this fraction, 1/3, is equivalent. Now, in my model, I've actually made 1, 2 out of 6. And they're equivalent, right? They're the same thing. Because as you can see, I just cut my pieces smaller, but the same amount of shaded. So now if I really rethink about what I have here, I have 2, 6, which was 1/3, but I made an equivalent fraction, plus 1, 6. And if I was to follow that algorithm, well, now that my denominators are the same, and then I add those, I get 3, 6. And we can look at that as a model as well. And I know things are a little messy on here. Let's see what we can do here. But look at the model of that. It's true. Here's my 6's, and I have 1, 2, 3 of them. 1, 2, 3, which is the same thing here. So again, let's just keep exploring. That is like really our only way to think about it. But let's think about what we did here. First, we looked at the denominator. Right, and then what we did is if they were unlike, which is really what we are focusing on, then our next step was to create an equivalent fraction. And I'm going to be transparent now that this is where all that great work with factors and multiples and all that stuff we did earlier, this is going to be a handy skill to help us with that for sure. And then we'll just add, right? We'll put it together, we'll finish the process. So let's play with that. Let's do this. Let's take 1/4 and let's add 3/12. All right, so here we go. First of all, are my denominators the same? And obviously they are not, so I can't just slide my denominator over and add my numerators. It won't work. So we're going to have to make an equivalent fraction. So we're going to have to make one of these fractions either out of 12 or the other one out of 4. So I'm going to make my two models. And here's 1/4. And this, let's see, we need 12. So let's do 1, 2, 3, 4, 5. Not like that. Let's make that better. 1, 2, 3, 4, 5. Cut that in half. There's 12s. Okay. And so let's think. Which one of these could we partition differently? Well, to me, it makes sense to come over here to 1/4 and see if we can't turn that into 12s. So let's see. 2. What if we went here? Here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 12, but my pieces aren't equal. My pieces aren't equal. So let's see. Let's go back to the drawing board. What else can we try here? Maybe we should probably have this shaded in so it makes sense. All right, let's, I went down the middle. Oh, I see. How about this? Let's just partition it. Let's copy this. All right, this line here, it's this line here. So I'm just going to go here, 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 here. There's 12, right? And so now, instead of 1/4, I've partitioned this into an equivalent fraction out of 12. There's 12 pieces now, and how many are shaded? Instead of one shaded section, I now have 1, 2, 3. I actually have 3 12s. And then if we look at our other model, this can stay as 12s, and we have 3 of them. And if we were to put those together, that would be 3 12s plus 3 12s. That tells me I'm going to have 6 12s, but let's use the model to help us do that. So again, boom, boom. Just going to copy, right? That's the cool thing about putting these models next to each other. You can copy, just straight copy them. That way you know they're the same size. 3, 4, 5, and 6. And that's true. 1, 2, 3, 4, 5, 6 pieces total, which again gets me to 6 12s. And that would make sense because again, once I do that equivalent fraction, I've taken 1/4. Oops, I don't want to erase. Taken 1/4 and I converted it, I changed it into 3/12. So then boom, slide and add. Okay, so let's just keep playing, right? It's the more we do it, the more it's gonna make some sense for us. So let's try a couple others. Again, unlike denominators. So let's say I have 1/6 and I'm adding 3/4. Okay, this one's going to be a little more of a challenge. So let's think about this. That first step always is like, is my denominator, are they the same, right? Are those denominators the same? And if so, then it's great. I can just add my numerators and slide over my denominator and I'm done. But that's not the case. They're not the same. So let's get equivalent. Let's make these equal. So, oof, yuck. I want my denominator to be the same. So this is in 6s and this is in 4ths. Let's see what we can do here. So here's 3/4 and then let's do 1. Nope. 1, 2. There's 6 and 1. Okay. All right. So this is going to be interesting. Like, how can we? Because in this case, I don't really see a way I can partition just one of these. I may actually have to start thinking about how do I partition both of them into an equal number. So let's see, let's start playing around. Let's see if I go here and I go here. That would be 1, 2, 3, 4, 5, 6, 7, 8 pieces. And that's not gonna really help me over here. I don't see 8 and 6 being friendly, right? When I think about like those multiples, right? Least common multiples or factors, common factors, like that doesn't really come in handy. So let's see, maybe I can use the other model to help. So this line, I'll come over and go here. I'll go over here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's see, 8. So see, this really isn't panning out. Like I'm trying to model this and it's just not really working for me. So let's try a different approach. Let's go back to that factor and let's think about, no, that just didn't work for me. Let's think about this idea of a common multiple, right? That LCM, because if I can find something that these two numbers have in common, then I can actually know how to change that model. So let's see here. 6 and 4, what do they share? This is 6, 12, 18. I'll just stop there because this is 4, 8, 12. Look at that. What I see here is they actually can share 12ths. So I actually want to think about how can I partition my models into 12ths? How can I make my denominator 12 for both of these models? So this is definitely a much more complex problem, but it's a good way to be thinking about it. Let's go here. Let's try. Let's see what we can do. So build a model. I want 6s first, right? So let's see. Let's go with 1. Nope. There. Okay, there's 6s. And then let's see if I went, oh, let's shade it first. Gotta make sure I'm doing the right things here. Okay. Now let's go. What if we went here, here, here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that works. So now that I know I can cut this into 12ths, this fraction just became 2/12 instead, right? And we're going to add that to this 3/4, but we want to make that 12. So again, see how I use that least common multiple? See how I did that to help me think about what is the common amount of pieces I should cut these into? So let's see. Let's first go with 3/4. I'm just going to use, it looks like things line up, right? These lines line up here. So I'm going to use this one and this one, cut it up, cut it up, cut it up. Does that 12? 1, 2, 3, 4, 5, 6 times, yep. So what does 3/4 become? Well, it now becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/12. Right? So that's like, if you see, that's what we did here. We used these equivalent fractions. We also even used our multiples to help us do this, because now we cut these two fractions and they're into equivalent pieces. So now this means I have 2/12 plus 9/12. And if I did our algorithm, that would get me 11/12, because now my denominator is the same, so I can just slide it over. So let's keep that in mind. We'll keep practicing this skill. There'll be more in the next video as we continue to explore this. But as always, thanks for watching, and we'll see you really soon.